Welcome to Following Swift Evolution. In this video, I want to talk about the proposal SE0202 called random unification. And it doesn't mean that they wanted to unify random bits and pieces of the standard library. No, what they wanted was to unify the random API. And by unify, we mean actually making one. Because up until now, we had to use the primitives provided by the different operative systems, like if you are used to arc for random, there was no API provided by the standard library, which means that if you wanted to deploy your app in different operative systems, like in Linux, for example, you then had to mess around with compiler directives to change your implementation based on the operative system. So this proposal came in order to solve this issue, to provide a standard library random API that basically allow us to not really care about which operative system we're deploying. And furthermore, we don't even have to be experts into random distributions, which is one of the issues that you often see come up when you work with random APIs. So the basics of this API is the random number generator protocol. If we take a look, this protocol is really simple. It just has a next function that returns an unsigned integer 64. What we can do with this protocol is we can create a type that it's, for example, my random number generator that conforms to this protocol. And once we have this, we just need to implement this provided next function that returns an integer 64, an unsigned integer 64. And here we can basically do whatever we want. We can even return fixed numbers, but for example, just as an example, we can keep using the arc for random actually if we import foundation, so we actually import the Darwin's API. And if we run arc for random and return an unsigned integer 64, this is everything we need to create a random number generator in this new Swift API. The way to use this is actually quite simple. You just need to create a random number generator, which is this type that we just did. And you can just, as you can see, simply just call next. And if we print this value, you can see that we get a number. But if we print it twice, well, we're just gonna get two different numbers from it, which is obviously because we're using the arc for random API. But that's the basics of the random number generator API. But don't worry, you don't have to provide this yourself. The standard library provides us with this system random number generator type, which it implements the operative system random facilities in this common API, so we don't have to worry about the difference between different systems and make sure that the distribution is the proper one and all that jazz. That's perfectly fine. Now, the thing to understand here is that you will rarely use this next API, because the nice thing is that the standard API has added random methods to specific types that allow us to just get random values from that type directly without having to create a random number generator ourselves. For example, if we want a random integer value, we can just call to the integer type this static method called random, and in here we can just pass a range. It's using this range type that we all know and love, and it basically makes super easier to return a random integer between two values. We can use the close range, the open range, but what if I want a random value, an integer random value? I don't have an upper or lower limit. Well, that's also easy because the integer value, like numeric values, has this static property that gives you the min and max values of the type. So in this case, you can just use this, and now it will give us a random integer value from the whole set of possible integer values. This can be done with integers. It can also be done with floats. For example, the most common case, if we want a value between 0 and 1, we can still use the float.random method to do it. The most curious one for me, the funny one, is that you can actually use a bool random, and in this case it just will give you a random value between true and false. Now, the nice thing about these methods is that you can use them like this, like we just did now, and by default they are actually, right now, they are using the system random number generator. But if you have your custom random generator that provides with a different distribution, or that you, for example, you can initialize it with a seed so it gives you predictable values, you can actually add a parameter called using here that you can pass your random number generator. But because when you call the next method in the random number generator, what it's happening is that it's assuming that you need to mutate some internal state. Basically, if you think as a random number generator just as going through a set of values and a list of random numbers, you need to actually mutate some internal state. So what is happening here is that to make it properly work with any kind of random number generator that needs to have mutation on its own state, it tells us that you need to pass as in-out value. That's why you actually need to define it as a bar and not as a let, because otherwise you cannot pass it. So right now, by just adding this new parameter into the random function call, you get different values based on the generator that you provided here. You can use these to create generators that have initial seed, so you get predictable values. For example, for unit testing, it's really useful. And thanks that you can inject your custom generators into all the APIs provided by standard library, means that you can have a fully unit tested application even if you're using random numbers inside. Another interesting part of the API that it's now provided by the standard library in terms of random methods is the addition of random methods into the collection. If you have any collection, in this case an array of strings, you actually can call random element, and this will give you a random element from the collection. This returns an optional, obviously, because you can have an empty collection. In that case, there is no element to return, but in this case, we can just force unwrap it and see what the result is. You can see that now it's Alex. If we run it, maybe it's the same, maybe it's another one, you see. But it's super interesting that we can now just get a random element for any collection that we have. One thing to notice about this, which is generally it's not going to be a problem for anybody developing normal applications, but if you want to run this, be careful with some kind of collections that have the maximum number of elements that they can hold bigger than the integer that it's using to get a random element, because in that case you can get unexpected behavior or even crashes. It's just something that you just need to keep in mind if you're dealing with dynamic collections that have this problem. The other thing that you can do with a collection is actually shuffle it, and we can, for example, do shuffled, so it returns a new version instead of the shuffle method that mutates it in place. And now you can see like George is the first one instead of Alex. All these APIs, they are not things that we are going to use on everyday development, but they are, for me at least, they are super useful things that it's nice to have in the standard library, so you don't even have to think about it when you require it. I often use this to create, for example, random colors when you're doing UI development. And talking about adding random functions into your own or existing types like the UI color, let's take a look at how we will do it. First, let's create an enum that represents some value that we're interested in. So here we just have an enum representing food with some nice emojis of different kinds of food. We actually use the case iterable protocol to give us a method to get all the cases from the enum. If you are more interested in this, I have another video talking about this Swift evolution proposal that you can check on the description. And now let's see how we could implement the same system as the standard library does to basically provide a random method. Let's say that what we want to do is get a random food. To do this, obviously we need to implement a random, but like what it's important to make sure is that we follow the convention that the standard library has specified. If we write this code like this is the guidelines that the standard library provides for getting random elements of a type. The first thing we want is implement a static function that it's called random, where you can pass the using argument an in-out number generator. You can use this to get just the type that you want, but the important thing is that we always provide a way to pass a custom random generator. Now, to make things simpler, for example, in this case, I don't really want to pass any custom number generator. And for that, we actually need to provide a second method that basically uses this custom random generator by default, and it calls the method that we just created. You probably are wondering why we just don't use default methods here and we say, okay, yeah, by default use the system random generator. Well, this actually doesn't work because the argument that we need to pass needs to be in out for the reasons we already talked about. And in that case, if we just do this system random number generator instance is going to be actually a constant instance, so there is no way for the in out to mutate this constant instance. It's not nice, but it's what we need to do is create a separate function that basically doesn't accept any parameter, and we create a bar random number generator here and we pass it into the function. This is probably, yes, it's mutating this, but we don't really care about it. And this is all I have to say about the new random generator API in Swift 4.2. I'm really pleased with the result of this proposal change, mainly because it gives us the flexibility to use custom random generators. We could even, for example, implement one based on the GameKit APIs for iOS and Mac. We can use other algorithms that you want, and anything custom that you do, it's still usable with the default random generation provided by the standard library, which is really cool. Also, all the types and extensions added to the standard library, like all these random methods on collection, they are really useful and they are really nice to have. Finally, Swift has a proper random API that we can all use without overthinking in which platform or which distribution we want. Remember to subscribe if you like this video, because we are gonna get more videos like this talking about all the different proposals that we are getting thanks to Swift Evolution. Thank you for watching and see you next time.